Sasical students. So we have seen yesterday, we studied about J.J. Thomson's model of the atom, right? We have already studied that the J.J. Thomson discovered canal rays, would say like electrons, J.J. Thomson. So the Dalton had proposed that atom is indestructible, indivisible, indestructible. The atom cannot be arranged into further small parts. But the discovery of proton and electron proved that that postulate of Dalton was wrong. Am I right? So we came to know that atom is having subparticles. But now the question was how those particles are arranged. So yesterday we studied about J.J. Thomson's model. So I think you remember J.J. Thomson proposed that atom is just like a just like a circle, just like a sphere rather. It's like a watermelon. The edible part of watermelon is red color, so that it's like positively charged sphere is equivalent to edible part of watermelon, and seeds are like the electrons embedded in that watermelon, the electrons. So, but then that postulate had one good advantage. What was a good advantage? He said that, if you remember, J.J. Thomson told that the amount of positive charge, and the amount of negative charge that is equal in an atom. So from this we understood that atom is actually electrically neutral. There is no there is no resultant charge on the atom. Okay? So that was one good postulate. The other postulate that protons are, he couldn't exactly tell the location of protons. Okay? So then students, after that came this model. We are going to talk about Rutherford model. Rutherford also got the Nobel Prize, students. That's the highest prestigious prize. He also got the Nobel Prize. So, in which year? In 1908. And Rutherford, Ernest Rutherford, is also known as father of nuclear physics. His work on nuclear physics was really great. So, what he did? Now we talk about alpha radiations. So, what are alpha radiations? Alpha radiations are, students, they are basically alpha particles. They are like alpha rays. Alpha particles are alpha rays also, or alpha radiations. They consist of two protons and two neutrons bond together. It's just like the helium 4 nucleus. Okay? In helium we have two protons and two neutrons. They are combined together, so that is one particle. Such particle is known as alpha particle. Okay, so if you just see, we have two protons, okay, or maybe two neutrons, you know this. So four particles, sum of four particles is like one alpha particle. This is alpha particle. So he basically bombarded alpha particles on gold foil, and then he observed the result. They were really astonishing results. So, so basically, Ernest Rutherford was interested in knowing how electrons are arranged, within an atom. Rutherford designed an experiment for this. So, what was the experiment he designed, students? In this experiment, a fast-moving alpha particles, it's written as A, activates alpha particles. It's written like this. One second. So it's written on rated A, rated alpha particles. So Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on thin gold foil. Now, students, the question comes: why gold foil? Why not aluminum or copper foil? Students, do you know about the property known as ductility,
Yes, sir.
and another property, malleability? In this, gold is in the top list. Gold, sona, it's in the top. It's ductile as well as malleable. You will not believe, students, in 1 gram of gold, 2 kilometer wire. 2 kilometer wire is approximately 2,000 meter long wire can be drawn. Such is the ductility of gold, and it is very malleable also. That means it can be, hammered into very small sheets. It's very malleable, very thin sheets. If I thinner is the sheet, better could be the results. That's what Ernest Rutherford, thought of. So what he has done. So let's see. So he chose aluminum sheet. So what was done? He selected gold foil because he wanted a thin layer as much as possible. So gold is very ductile and malleable, already explained. This gold foil was about 1,000 atoms thick. Means, what is the meaning of this? That if let's say this is the size of an atom. So if you put 1,000 atoms, the atom is very, very small, students. So that much thick was it. Still, it will be very thin. The gold foil was very, very thin. Okay, so 100,000 atoms thick. Now a particle. Now he's talking about alpha particles. Alpha particle, the doubly charged helium ions. What is the meaning of ion, student? You just see. Let's say we talk about. Let's say we talk about anything. Let's say we talk about some element which is having one electron in the outermost orbit. Okay, so let's say obviously in the shell, smaller shell, it will be having its octet complete. So because it has only one electron, it will be very reactive. For example, if you take the case of sodium and potassium, these two elements are so reactive. You have to have a jar, and you have to have a kerosene oil, so they will catch fire if you put them in the air. They are so reactive. In order to stop its reaction with oxygen, they are stored in a jar containing kerosene oil. Why? Because both of them, they are in the same column of periodic table. So their valency is 1. Valency is 1 means in the outermost orbit, how many electrons are there? Only one electron. So, it somehow wants to get rid of this electron, so that the octet, is, yes, Deep, so that the octet is complete.
Complete.
Okay? Its octet is already complete in this shell, in prior to this shell, no? So, but then because of this electron, this is a problem, So, what happens? Uh, you know, you know, the sodium, whenever it comes in contact with chlorine is one electron short, so it will give its uh, electron to sodium. So actually, you see that as J.J. Thomson had predicted, that atom is electrically stable. How electrical stable will be there? Means number of positive charge is equal to number of negative charge. Now, obviously, suppose sodium is there. So sodium is, it wants to complete the octet. In the earning for completing the octet, it will react with chlorine and ultimately making our namak, salt, NaCl, sodium chloride. So what happens when the Na gives the electron to chlorine? Na gets positive charge. Because electron is gone, electrons are always negatively charged. you know so chlorine was also initially electrically neutral, but when it gained the electron, see, chlorine was already having uh, 7 electrons in the outermost orbit. I think the atomic number of chlorine is 17. So how 17 electrons will be arranged? 2, then 8, right? Octet complete 10. In the third orbit, it will have 7 electrons, right? 1, 2, 3, 4, 5, 6, 7. So it's all mathematics going here. One electron is short that it gets from sodium. So this electron now, initially, before acceptance of this electron, the chlorine was electrically neutral. But when the electron has come, excess electron, then what will be the charge of chlorine?
Negative.
Negative charge. Why? Because electron is having negative charge. You whatever you are getting, आपका behavior वैसे हो जाएगा ना. Now you sit with a student who wants to top in some competition. You will also think of topping. You sit with a person who is very lazy. You will get very lazy. So chlorine is getting the company of a negatively charged element. So the whole chlorine gets negative. Okay. If chlorine was losing some electrons, it would get positive, but it will never lose electrons because the bonding energy is so strong in the 7 electrons, it will never allow any electron to go out. Rather, it will accept the electron to complete the octet. Okay. So, this is the meaning of ion. We have positive ions and we have negative ions also. Can anyone tell me what is cation and one is anion? One of them is cation, one of them is anion.
So the positive ion is cation and the negative one is anion.
Very,
And Na is cation here and Cl is anion.
very right. So you just say not applicable. You always remember. So A for anion, N for negative. So not applicable, right? N for negative, A for ion. Any ion which is negatively charged, that's like, an ion. Fine. So these are the ions. Okay. So this is alpha particles are doubly charged helium ions. Okay. Fine. Since they have a mass of 4U. Now, what is this U? So students, this is like the internationally accepted. Initially, it used to be AMU, atomic mass unit. Now we just go for the smallest atomic mass we take as U. We will explain you later how C12 is involved in the measurement of U. In the later lectures, we'll inform you. Fast moving alpha particles have a considerable amount of energy. They have a lot of energy. They have a lot of energy. We want to use this energy. Okay. So what's happening? It was expected that alpha particles would be deflected by subatomic particles in the gold atoms. I'll tell you what is happening. Okay. So students, in some different platform, give me a second. Why it says that it was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles, not A particles, I'm sorry, it's alpha particle. Since the alpha particles were much heavier than protons, why they are heavier? Because we have seen one alpha particle means how many protons? One alpha particles means two protons and two not electrons, two neutrons. Okay, this complete bonding is said to be one alpha particle. Okay, so obviously you can say approximately 4 times more heavier than the protons. He did not expect to see large deflections. Okay, so what is this deflection he is talking about, and what is this? When he why it's written he did not expect large deflections. It was expected that alpha particles would be deflected by subatomic particles in gold atoms. Since the alpha particles were much heavier, he did not expect to see large deflections. Okay, students, let me explain this. It's very interesting. Then you will understand what he did and what was the whole story about. Okay. See here, students, you must have played kanchas. I, I maybe like I have played. Kanchas are small marbles. So you strike them with one marble, and then it will go in some other direction. So when this marble, spherical shape, the glass kind of thing. So when this, when it strikes on this, what will happen? If it strikes exactly in the center, it will move in the same direction. But normally it may not strike at the center. It may strike, little bit here or little bit here. So when it will strike here, it will get deflected in this direction. If it strikes here, it will get deflected in this direction because of the component of forces, right? Every force can be split into two components. This is the force, this is the y component, this is the x component. Both components will be smaller than the actual force. Okay, vectors, all are vectors. Okay, so basically, or you can say like in the game of pool, billiards, they have spherical balls. So when one ball is hitting the other ball, naturally it will be deflected either in this direction or in this direction or in some other direction. So many alpha particles are being bombarded. Okay, now he says it's written he did not expect large deflections. Why? Alpha, see, now if you are having a kancha like this, a very big, a very big kancha, let us say on this very big kancha or this marble, a small marble you are hitting, what will happen? This marble, the hitting marble will get deflected. This will not get much deflected. Am I right?
Yes, sir.
Deflected means change
Yes.
of direction. Okay, another thing. Now, if this one will hit this, what will happen? Again, this will not get much deflected. Rather, this will get much deflected. Why? Because momentum, mass into velocity. Its mass is bigger, velocity may be same. Its mass is very small, velocity may be bigger or whatever it is. Okay. So this is a thing. So that's why he did not expect much deflection because alpha particles were like this. Am I right? So, but he got the deflections. Then the J.J. Thomson model that the protons are like scattered kind of thing, positively charged is scattered all across the sphere, and electrons are embedded in them was somehow looking like it's wrong. It's a wrong way the model has been proposed by J.J. Thomson. So students, you just see the difference between a student, even if he clears IIT, and a scientist. A student, it's always expected he gets 100% results, 100% accuracy, 100% precision, 100% time. All parents, teachers, everyone is, always with a danda on a student. I want 100%, 100% time utilization. But J.J. Thomson, even though he got a wrong result, still because of his work, he was given Nobel Prize. That is the difference between a scientist and a normal person. So a scientist, he, what we are doing, I'm just reading a book, I've read book, I got knowledge, I'm teaching you. There's no scientific work in this. Okay, if I teach you well, that's like somebody, some students can say a little better teacher. But a scientist, even if he does a discovery which is proven wrong by other scientists, still people acknowledge his work, but people acknowledge his creativity, that he has moved the present science by an inch or by a centimeter ahead. The knowledge is added in the books. So that's why I'm saying, you must like the concepts always. Okay, it's very important. So, okay. So now we have to understand what were the good things in Rutherford's experiment and what were the drawbacks of Rutherford's experiment. Let us see. Okay, let's go further. समझ आ रही है? थोड़ी बहुत समझ आ रही है? Okay. So students, what were the observations? Okay, you must have got an idea. Most of the fast moving alpha particles passed, see, very interesting and very important. Most of the alpha particles passed straight through the gold foil. Okay, student, here I am telling you, suppose, uh, suppose there is a windmill. Have you seen a windmill, students? Very big blades, windmills, they keep rotating. Suppose a bird is coming from here, and in the line of flight of bird, suppose he gets hit by the blade. What will happen? It may die, bird may get injured, or bird may get deflected in some other direction. Am I right? Suppose the bird is passing through this area in wind. See, this is the rotor. This is I don't know, rotor or what they say. So only this much area is occupied by the blades of the windmill. If a bird comes and directly hits here, what will happen? The bird will get injured, it will die, or it will get deflected, right? But if the bird passes from this much area, the bird will not be hurt. Am I right, Deep and Hamza?
Yes, sir.
Because there is air here, bird will keep simply pass, simply fly as it is flying in the air. Something like this is happening here. Most of the fast moving alpha particles passed straight through the foil. If this was the gold foil, most of the particles, they were not deflected. He was expecting not large deflections, but he was expecting some deflections. Why? Can anyone tell? Because J.J. Thomson had told that all across the sphere, like the Christmas pudding, what is there? The positive charge is there. So he thought it will hit with the protons eventually here, here, here. It will hit with the protons a little bit if it is going like this. So little bit change in the uh, direction will be there. But most of them, they passed through the foil विदाउट चेंजिंग डायरेक्शन उनकी डायरेक्शन चेंज नहीं हुई सीधा ही पास हो गए ओ नाउ एनी स्टूडेंट कैन टेल व्हाट डज इट मीन बहुत सारे अल्फा पार्टिकल्स तो डिफ्लेक्ट हुए ही नहीं सीधा ही पास करके इसका मतलब उनको रोकने के लिए उनके रेजिस्टेंस के लिए कुछ भी आगे नहीं था ब्यूटीफुल उनको रेजिस्टेंस करने के लिए कुछ था ही नहीं स्टूडेंट्स आई एम टेलिंग यू आपको बड़ा मजा आएगा ये यू विल रिमेंबर इट कि हाँ रदरफोर्ड ने क्या एक्सपेरिमेंट किया कैसे किया आप भी ऐसे बनो दूसरा उसने फिर देखा दूसरा पढ़ो प्रणव आगे
Some of the alpha particles were deflected by the foil by small angles.
अच्छा थोड़े से अल्फा पार्टिकल जो हैं वो डिफ्लेक्ट हुए वो भी बाय स्मॉल एंगल्स चलो ये तो हम ऑलरेडी एक्सपेक्ट कर रहे थे ना कि जब भी उनको आगे से भी प्रोटॉन मिलेगा प्रोटॉन का जो मास है वो अल्फा पार्टिकल से अप्रोक्सीमेटली 1/4 1/4 हिस्सा है ना तो ठीक है थोड़ी सा डिफ्लेक्शन हुई बट थोड़े से पार्टिकल्स की डिफ्लेक्शन हुई दूसरा सरप्राइजिंगली 1 out of every 12,000 particles appeared to rebound. अच्छा बच्चों रीबाउंड का मतलब क्या हुआ मान लो
Deflect.
हाँ बोलो
Bounce back.
बाउंस बैक ब्यूटीफुल क्या इंटरेस्टिंग चीज हुई मान लो ये कोई वॉल है ठीक है बच्चों एंड आई थ्रो ए बॉल ऑन द वॉल तो बॉल क्या क्या करेगी बॉल विल बी रीबाउंड वापस आ जाएगी वैसे ही अगर बॉल इतनी सी है और बहुत बड़ा एक मतलब बॉल है बहुत बड़ा स्फीयर टाइप है इसको इसमें मारोगे फर्क ही नहीं पड़ेगा वापस आ जाएगा इसको बोलते हैं रीबाउंड 3 ऑब्जर्वेशंस आई किसकी रदरफोर्ड एक्सपेरिमेंट की पहली ऑब्जर्वेशन कोई बच्चा देखने के बगैर बता सकता है देखने के बगैर पहली ऑब्जर्वेशन क्या थी मैं भी नहीं देख रहा मैं भी सोच रहा हूँ पहली ऑब्जर्वेशन क्या थी रदरफोर्ड की बोलो बच्चों कि थोड़े से पार्टिकल बहुत कम मतलब 12,000 में से एक पार्टिकल 12,000 में से एक पार्टिकल वो वापस आ गया मतलब कि वो आगे गया फाइल में और वो जितने मतलब कि 12,000 पार्टिकल मान लो मगर छोड़े तो 12,000 में से बस एक पार्टिकल जो है वो बाउंस बैक हो गया मतलब बिल्कुल जैसे वो जिस डायरेक्शन में गया उसी डायरेक्शन में वापस आ गया अच्छा बच्चों प्लीज टेल मी पार्टिकल कभी भी, अल्फा पार्टिकल वैसे इतना हैवी है, तो अल्फा पार्टिकल बाउंस बैक क्यों हुआ? लेकिन कभी भी कोई हमारी बॉल बाउंस बैक कब करेगी? जब आगे वाला मटेरियल की डेंसिटी बहुत ज़्यादा है, अब भरकम, हैवी भरकम कोई मटेरियल है, एम आई राइट? तभी हमारी
Yes, sir.
बॉल, अगर मान लो हमने बॉल फेंकी है, आगे मान लो वो है रुई है, रुई का एक क्या बोलते हैं छोटा सा वॉल्यूम है, वो रुई को लेकर उसमें से पार करके निकल जाएगी, एम आई राइट? बिल्कुल वैसे ही पहले ही देखो ऑब्जर्वेशन कि मोस्ट ऑफ द फास्ट मूविंग अल्फा पार्टिकल्स निकल गए, सारे पार्टिकल निकल गए मोस्ट ऑफ देम। थोड़े से पार्टिकल जो है वो कुछ एंगल से डिफ्लेक्ट हुए, और सरप्राइजिंगली बहुत कम, कितनी परसेंटेज बनती है? एक भी नहीं, 0.00001% पार्टिकल रीबाउंड हुए। ठीक है, अब इनकी कंक्लूजन हम पढ़ेंगे नहीं, हम खुद इसको स्टडी करेंगे। देखो, हम देखेंगे इससे क्या आइडिया लग रहा है कि मतलब कैसा होगा उसकी शेप एटम की। हाँ? ये देखो बच्चों, ये हमारा, ये आपका मान लो एटम है, सॉरी, ये आपका मान लो एटम है। ठीक है, अब बहुत कम पार्टिकल वापस आ रहे हैं, 12,000 में से कितने पार्टिकल बोलो बच्चों? सिर्फ
10,000.
वन। इसका मतलब क्या हुआ कि कोई इसमें ऐसी चीज है इस एटम में जिसकी जो मास डेंसिटी है बहुत मास
ज़्यादा.
ज्यादा है। और अब ये आप आइडिया बताओ कि क्या वो जो मास डेंसिटी बहुत ज्यादा है, वो क्या जैसे जे जे थॉमसन ने बोला था कि सारे हर तरफ वो फैली हुई है, कि छोटे से एरिया में है, छोटे से
हर जगह.
छोटे से वॉल्यूम में? छोटे से वॉल्यूम में क्यों हम बोल सकते हैं कि अगर वो बहुत ज्यादा उसका एरिया होता तो फिर तो बहुत सारे अल्फा पार्टिकल्स बाउंस बैक हो जाते, मगर वो बहुत थोड़े 12,000 में से एक ही पार्टिकल बाउंस बैक हुआ है। इसका मतलब ये हुआ कि कुछ ऐसी चीज है जहां पर काफी ज्यादा कंसंट्रेशन है मास, है ना। और बाकी उसने ये देखा हमने कि मैक्सिमम पार्टिकल्स तो है वो अनडिफ्लेक्टेड ही चले गए, मतलब यहाँ से आए कुछ भी नहीं था, चले गए, वो यहाँ से आए चले गए, यहाँ से आए चले गए, यहाँ से आए चले गए, उनको कोई फर्क ही नहीं पड़ा। और थोड़े से पार्टिकल जो है डिफ्लेक्ट हुए, मतलब जैसे वो यहाँ हिट किए थोड़े डिफ्लेक्ट हो गए, यहाँ हिट किए थोड़े डिफ्लेक्ट हो गए, और जो इसके सेंटर में आया वो कहाँ गया? बिल्कुल सही,
Bounce back.
वो बाउंस बैक हो गया, बिल्कुल ठीक। आई थिंक आपको समझ आ गया। अब आगे चलें, अभी इनका पढ़ते हैं और इसको लेक्चर को खत्म करते हैं। कंक्लूजन देखो, वही कंक्लूजन निकलेगी। मोस्ट ऑफ द स्पेसेस इनसाइड द एटम इज, क्या लिखा है प्रणव? देखो अभी
Empty.
वाली बात,
Empty.
ये वही बात हो गई विंडमिल वाली थी कि ब्लेड्स का जो एरिया बहुत छोटा सा है, बाकी एरिया सारा तो विंडमिल के रोटर का दीप खाली है, तो बर्ड्स आए, बर्ड्स चले गए वहां से, है ना, अल्फा पार्टिकल्स आए चले गए। मतलब इसकी कंक्लूजन क्या निकली कि वेरी फ्यू, मोस्ट ऑफ द स्पेस इनसाइड द एटम इज एम्प्टी, ये पहली जजमेंट है। ठीक है, बिकॉज अल्फा पार्टिकल जो है pass through the gold foil without getting deflected. Good. Number 2, very few particles were deflected from the path, मतलब थोड़े से पार्टिकल डिफ्लेक्ट हुए, इंडिकेटिंग पॉजिटिव चार्ज ऑफ द एटम। जो पॉजिटिव चार्ज है वो occupies very little space। क्या मजेदार चीज है, थोड़े सा स्पेस है उसमें, अभी वो अगर वो ज्यादा स्पेस में होता तो बहुत सारे पार्टिकल्स बाउंस बैक हो जाते। तीसरा, जो बाउंस बैक हुए, वेरी स्मॉल फ्रैक्शन ऑफ अल्फा पार्टिकल्स वर डिफ्लेक्टेड बाय, ये क्या लिखा है, कुछ और है, 1800
1800.
deflected, sorry, indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom। दोबारा पढ़ो मनसिमरत इसको, ये वाला थर्ड पॉइंट।
Third point, sir, a very small fraction of particles were deflected by 1800, indicating that all the positive charge and mass of
ये
the
1800 नहीं है, दिस इज 180 डिग्री। 180 डिग्री का मतलब क्या हुआ कि ऐसे आया, अगर तो
Straight line.
अगर तो ऐसे डिफ्लेक्ट हो जाता ये एंगल होता, ऐसे आया ऐसे डिफ्लेक्ट हो गया, तो इन दोनों के बीच का एंगल क्या है? 180
180 degree.
डिग्री। वेरी गुड। इसका मतलब वो जो, वही बात आ गई कि उन्होंने अंदाजा लगाया कि वो जो पॉजिटिव चार्ज है वो कहीं बीच में कंसंट्रेटेड है ना, और वो उसकी डेंसिटी मास इतना ज़्यादा है, इतनी ज़्यादा कंसंट्रेशन है उसकी, कि वो थोड़े से पार्टिकल जो इसको हिट किए वो वापस आ गए। वो कितने पार्टिकल वापस आए? 1/1200 नहीं, 12,000। ओके। अब रदरफोर्ड ने इसके बेसिस पर मॉडल प्रपोज क्या किया, बड़े इंटरेस्टिंग है फिजिक्स बच्चों। रदरफोर्ड ने मॉडल प्रपोज क्या किया, ठीक है क्या? नंबर 1, इलेक्ट्रॉन्स रिवॉल्व अराउंड द न्यूक्लियस इन सर्कुलर पाथ। आइडिया लग गया उसको कि इलेक्ट्रॉन्स का तो मास ऐसे बहुत कम है, तो वो उसके वो मतलब न्यूक्लियस जो है अच्छा न्यूक्लियस की सबसे पहले इसने ये बहुत बढ़िया अचीवमेंट हुई कि इसने डिफाइन कर दिया कि हाँ न्यूक्लियस है। न्यूक्लियस का मतलब सेंटर पॉइंट है, और वो सेंटर पॉइंट में सारे का सारा मास है, तभी तो 1/12,000 पार्टिकल वापस आए। पॉजिटिवली चार्ज सेंटर इन एन एटम नोन एज न्यूक्लियस। बाद में मालूम चला एक्सपेरिमेंट से ये सही थी बात। नियरली ऑल द मास ऑफ एटम रिजाइड्स इन द न्यूक्लियस, मतलब जितने भी एटम का मास है वो सारा मास न्यूक्लियस में है मोस्टली, 99% मास। इलेक्ट्रॉन रिवॉल्व अराउंड द न्यूक्लियस इन सर्कुलर पाथ। अब ये सर्कुलर पाथ वाली बात सही है कि नहीं, आगे जाके देखते हैं। साइज ऑफ न्यूक्लियस बहुत छोटा है एज कम्पेयर टू साइज ऑफ एटम, वो मैंने आपको पहले बता दिया है कि एटम का साइज कितना, अगर अपन ले 10 किलोमीटर, तो इसमें न्यूक्लियस कितना जगह लेता है? सिर्फ एक टेनिस बॉल जितनी, ठीक है जी। अब आगे इसके बच्चों ड्रॉबैक्स, हमारे पास 3 मिनट है, आओ हम वो भी कर लें। ड्रॉबैक्स नहीं आए, मॉडल प्रपोज बाय फॉर, मैं अभी आपको बता रहा हूँ इसके